Welcome to the ultrasound course. This is the first lecture and we're going to discuss the machine settings. Settings is very important to start any ultrasound course with, whether it is the Doppler or abdomen or gynae, obstetrics, whatever. It is absolutely crucial that you know how to set the parameters and to control everything in your machine. Especially in the Doppler, being very technical, and there are a lot of things to calibrate. But this will be of great value. It is indispensable actually in all types of ultrasound examination. So it is very, very important to know and to handle it very well. It's not just an intro that you can bypass. No, it is very important. So let's go ahead and see what we have. Okay, we have here an example of an ultrasound machine. This is a Mandray, and I'm quite sure that there are a lot of other ultrasound machines, and you might be working with another Siemens, GE, whatever. The principle would be the same, okay? However, there will be some differences. I'm quite sure that many of you will ask me later that the knobs are slightly different. The function cannot be through the same button or interface labeled differently. All these differences might be present, of course, due to manufacturer differences. However, the principle is the same, so I want you to pay very close attention and to take notes. And the very important thing is that you familiarize yourself immediately with the machine you are actually going to use in your health unit or your clinic, in your hospital, whatever. Familiarize yourself with the machine you will work with, okay, and know where everything is. Should you find something different or some function you cannot find, then you can ask a more senior member in your team or Google it with the name of your machine, the manufacturer manuals or anything, and or you might ask the maintenance team, the engineer responsible to show you where everything is. But the essential thing is that you familiarize yourself with everything in your machine. It is a tool you are going to use, so it is important that you know how to use it well. Okay, so let's start with something very simple, and that is registering your patient. Okay, registering the patient might be under the name of patient as such, or registration, whatever. This will get you like this. This will get you to a menu like this. Okay. In this menu, as we can see here, we will log into the patient's data. We have here the patient ID if you are in a hospital. We have here the first and the last name. Okay. We have here the age. You can just log it right away or write the date of birth and the gender. Okay. It's important not to forget the gender depending on the first name, because some names might go both ways. Like in Egypt, we have a name called Wissam. Wissam might be a girl or boy. So, in order to know the gender of the patient, you have to log it. I don't know if you have other such names in your country or not, but it is important that you log in the data of your patient. I know that this is routine, but routine for a reason, because logging the data of your patient will make the pictures all labeled. And so should you want to get to certain picture at the end of the day, when you have a lot of data and you want to make sure of something or there's a medical legal issue, it is of course important that everything is organized and looked in the name in the right manner, so that you can avoid any confusion or any mistake. Okay, so now we have logged in the patient by logging into the new patient. Okay, now we will choose the examination. Okay, we have here the new examination. Now, there are of course many examinations done by ultrasound, like the abdomen, like the obstetrics, like the gynae, like the cardiology. Now we will choose the vascular. Okay, so far so good. These are just very simple steps in the beginning. Okay, now we have here an example of how doing these simple steps initially will give you the best initial setup. Now we have here picture of the liver, okay, and this is the right kidney. As we can see here, there's part of the right kidney that's not really clear. Okay, but let's look into the image a little bit more. Now here we find something very peculiar. The type of examination set in the machine is obstetrics. So the machine thinks we're doing obstetrics. Okay, now the pre-settings in the machine are calibrated or optimized for obstetric examination. Now, are we doing obstetric examination? Obviously not. We're doing abdominal. So by simply changing this preset into abdomen as such, okay, what happened? What happened is that the picture is got significantly better, a little bit better. The lower part of the kidney now can be seen clearly. We have not changed anything. Of course, we learn more complex stuff, but this simple initial step will give you the best presettings in the machine for every certain examination. Okay? Okay. This is quite simple. We're just warming up. Now the probe. Now we will choose the probe, okay, we are going to work with. We have here the 4D probe, the curvilinear probe one is used for more deeper structure like the abdomen, and the superficial linear probe. Now we're going to choose it. By choosing it, the machine will automatically suggest the examinations done by this probe, like the thyroid, the breast, musculoskeletal, etc., etc. Now we will choose the carotid. Okay. So what have we done till now? Just simple stuff. We have registered the patient, we've chosen the time of examination and the transducer. Quite simple. It's just warming up. Now, here we're going to do the real work here. Now we have here the V mode, the color mode, and the pulse wave. Now these are the three main things in our standard Doppler examination. The B mode controls the basic ultrasound picture, and this is used for almost all ultrasound examinations and in Doppler, of course, but in Doppler we will proceed to other two things, okay? How having to know this quite well will be useful to you in all times of examination and in Doppler, of course. Now the color mode here makes you control the color pattern, okay, how to calibrate it, how to optimize it in order to have the right color pattern and to proceed with your examination. And here your pulse wave, okay, knob in order also to make you obtain the best pulse wave. Okay, so we have to master these three functions really well. Okay, let's see how we can do this. Voila, this is how we can do this. This is the roadmap, okay? In this very nice list, okay, we will learn the main points or main set of parameters that we have to control in order to know how to do the examination swiftly and without problems and to reach our diagnosis right. Now, first we have the B mode. As we said, the basic ultrasound picture. And in the B mode, we're going to discuss 9 points, okay? Okay. Then the color mode, we'll discuss 4 points, and then the pulse wave, the rest of the 9, that is 5 points. All in all, we have here 18 points. Now, these 18 points is the work of our lecture today. Okay, I want you, my goal is that you memorize these 18 points. Okay, I want you to memorize them very, very well so that you can apply them, okay, right away. It's really, really important to apply them right away. Okay, before delving into these deep waters of our list, okay, I'm gonna give you a little break. But in this break, I'm gonna tell you the story of this driver. Okay, this driver is now doing what? He is driving, and he seemed to be a busy man. He didn't have his breakfast, so he grabbed his coffee and he's having his donut while driving. Okay, and he might be on the phone with his earbuds in his ear, and he might be telling his comrades or colleagues about stuff in work, or might be doing whatever on the phone or listening to the radio. Okay, he's doing a lot of stuff. He's driving, he's eating, he's talking, all of this in the same time. But let's go back in time, okay, when you first learned how to drive, and you might relate to this, you might have gone through this experience, as many of us have. At first, it was really perplexing. It was very difficult. You have to control the steering well. You have to control the gear or the vitesse. You have to put your feet, sit your feet right on the gas or on the brakes or on the embrayage if it was manual. And you have to look at the side mirrors. You have to keep your eyes on the road and pay very close attention. There might be a kid crossing the street. You have to know when there is a crossroads and to slow down, and etc., etc. All of this. It seemed really very overwhelming. All of this while controlling your car. You have to pay attention to the road itself, to where you are going, and to controlling your car. So this might seem a lot to you, and it was a lot in the beginning, but with practice, all of this is just going to your subconscious. You can do it effortlessly and spontaneously, like second nature, without thinking, to the extent that you can actually do other stuff while driving, like eating, like talking. Okay, so to this extent, you can handle and master the driving. Of course, I do not advise you to have your breakfast or to eat while driving. It's illegal in some countries, but this is just to illustrate the idea of multitasking. Now let's get back to the list. Our mission is that you understand these 18 points. This is what we're going to do, explain them. And then what you are going to do, and you should do, is that you apply them and practice them right away. At first, you will do some effort to remember them, and to remind yourself of those 18 points, okay? And then you will start to remember them one by one, bit by bit, by doing a lot of examinations and doing a lot of practice. You will get to know them effortlessly, to the extent, just as like this driver, you can master and handle your machine effortlessly, spontaneously, and doing the calibration automatically while doing your examination flawlessly and comfortably as well. So this is the goal. Let's do the first part of it, understanding and explaining, then you can do the rest. I'm going to help you with some of the memorizing. I'm going to suggest some mnemonics, but you have to really sip in these list and remind yourself constantly with it. Okay, do whatever you think, print it out, put it on your pinboard, in your clinic, or just look at them in the morning, whatever. Just try to remember them initially. Okay, so let's start. Now we have the B mode here. Now, the B mode now is to obtain the best ultrasound picture, okay? Now we want to remember three set of parameters here, okay? In order to remember them, what we are doing right now, we are explaining how to do the Doppler in order to examine the vessels. And in the vessels runs the blood. And the main components of your blood are the RBCs. Now I'm substituting the C for D for Doppler. That this will give us what? This will give us the RBD, okay? Now the R is the resolution, the B is the brightness, and the D is the depth, okay? In every one of these 3 points, we have another 3 points, so that will give us 3 by 3. Easy to remember, okay? Now, let's see what are these 9 points. Let's go. Okay, let's start the B mode. Okay, but before starting in, I'm going to give you a little teaser, a little mind teaser, okay, something to think about, okay. Now we have here these two buttons, and these are related, of course, to our issue today. So, what are these buttons? We have here a button named CW and another one named power. Now, I want you to tell me what are these buttons or what are their function. Okay, let's start with the CW. Anyone has any idea what does it do? Mm, what does it do? The CW. Okay, bravo. I see that some of you got it right. It is the continuous wave. Bravo. Continuous wave. Now, do we normally use it as a standard in our ultrasound examination? The answer is no, we do not use it. It is used mainly by the echocardiographers. Okay, should you find it activated, just leave it like this, or you have to deactivate it? Yes, okay, that's right, absolutely correct. You have to deactivate it before carrying on with the exam. Okay, so that's all for the CW. Now, what is this power? Anyone has any idea? What does this power do? Yes, you're right. It is the Bauer Doppler. It is the Bauer Doppler. As you can see, it is related to the color. It can detect any color in the image, okay? Any flow, irrespective of its direction. Do not tell us information about direction, just tell us that there is flow. Okay, so now let's get into business. The B mode. We will start with the D. As we said, we have here our little mnemonic RBD. Okay. We have here the depth. We'll start with the D. And here the R, here this is the brightness, and this is resolution. We'll start with the depth. The depth itself. Now, what do we mean by depth? Yeah, let's look into the image. Now, in this lecture, we're going to look at everything in our image, okay? We have to understand things. You know, like clear vision, when you do something, understanding it will give you the ease, okay? It will give you control over your machine. It will make you understand everything in your picture so that you can control it and know how it is set, how it is calibrated. If it is changed for whatever reason, another practitioner has changed the parameters, for example, you will know, and you will know how to modify. So you will not be at a loss. Okay. So this is one of the goals, and inshallah, one by one, we're going to reach there. Okay. So we have here on the sidebar some numbers. What are these numbers? Anyone has any idea? Yes, absolutely correct. It's the depth we are talking about. The depth. These are the depth of the penetrating ultrasound waves. So in this picture, it's around 6 centimeters. Okay, it's around 6 centimeters. And the object of our interest is, let's say, the carotid or the thyroid. They are, let's say, the carotid around 3 centimeters deep. Now, if I stick a needle in the patient's neck, hypothetically 3 centimeters deep, I'd be in his carotid. Okay, so the carotid, the object of our interest, is in this part of the image, whilst all of this is new without use. Now, would you describe this as a good picture, as a good image? Yeah, I agree with you. It is not, because most of the image, I mean, more than half of it is black, is without use. Now, by simply calibrating the depth into more reasonable depth according to our object of interest. Now, our object of interest is here, so here the depth is what, like 3.5. Okay, so that's okay. Now, the center of our vision, the carotid, is in the center of our vision, and it is filling the image and we can see it right. Okay, so we have to calibrate the depth, okay, according to our object of interest, so we can make use of all of the picture. Okay, let's see another example. Now, what we are examining here, we are examining the pancreas. Okay, now here is the pancreas, here is the spine, and they are stuck in the upper part of the image, quite in the periphery, whilst the rest of the image is without hues. Now, by simply calibrating the depth, we have the pancreas filling in the image more evident in the spine here. Now, I would say that this is a better image. Would you agree with me? Okay, so this is how we can simply adjust the depth to make the image better. Okay, now here another related thing to the depth, but another function. Okay, now again, in the depth, what have we done? I'm sorry. Okay, in the depth, we have chosen the extent of our ultrasound waves to cover this area, or to extend deeper, or to extend deeper. But in the zoom, we don't do this. The depth is the same. We do not change it. We simply choose part of the image without changing the depth. We just choose one part of the image to look at more carefully or more extensively, and this is by magnifying it, just as like we did here by a magnifying glass. Now, how can we do this? Usually the zoom has separate knob or button. Here it is a rotatory knob where you can move right or left and choose the area of interest you want to zoom in. Let's see how can we do this and how can this be applied on our ultrasound real images. Okay, let's look here. What do we have here? This is a picture of the carotid again. Now let's look at this. What about the depth? Is it okay here? The depth is around 3 and the carotid is filling in the image. There's hardly, just very small part here that's black at the end of the picture. So the depth here is okay. The depth is okay. Voila. Yeah. So what happened here? The depth, as we can see, is 1, 2, 3. In this image, did we change the depth? No, we can see the same. There's something peculiar here. Number 3 and number 1, you can hardly see. Number 2 is magnified. This can give you a clue. What happens here is that we have zoomed in on number 2, roughly. So this carotid, okay, is magnified this way. Okay, it's magnified. So we it is magnified. So this okay hypoechoic part has gone into this. Look how big it has got, and this echogenic part is in here. And the lumen, look at the lumen. Okay, and this part has grown into this part. So everything's got bigger, it's magnified, but we have not changed the depth. We merely chose one part of the image to magnify and to look at closely and carefully. Okay. Okay, so why? Okay, let's go back to it. So why would we do this? I mean, why zooming in? The image is okay here. There must be something that we want to know. Okay, if we want, let's say, measure the intimal media thickness, it is this part here. Like, look at it here. Voila. Now you can assess it better and measure it more accurately. So this is the application, how we can use this zoom, okay, function in our work. Okay, another picture here. We have here the gallbladder. By zooming in it, we can look into it to see if there is any stone or anything that assists the lumen, whatever we want to do. Now here we can appreciate the difference between the zoom and the depth. Now here, this is the image. When you press on the zoom, usually a zooming box appears as such. So the depth is the same. We just have chosen this part of the image in order to magnify and to look at very closely. Now it has gone into this. Now we can see the portal with its main branches more evidently and more clearly as in the second image. Okay, so this is the zoom. Now we are still in the depth. Okay, we have discussed the depth itself, okay, and the zoom function. Zoom, we have discussed depth itself, the zoom function. Now we will discuss something very interesting. I don't know if you know it or not, but it's very interesting. It is the wide view. This is a very interesting function. It will give you a more integral picture. Let's see how it works. Okay. Normally in our superficial linear probe, the waves, okay, are in this manner. They are emitted in this manner, almost, or they are really vertical, very straight. So the resulting picture would be rectangular, equivalent to the waves, right? But when we activate this function, what happens? We ask the machine to make the waves emitted, the ultrasound waves emitted, to extend a little bit outwards, to cover an even bigger area. Okay, how can this be? Let's see. Okay, we have here a neck examination, okay, and we are examining the thyroid. This is the standard picture when we use the superficial linear probe. Now our edges are almost straight, they are straight, they are vertical as such, and we have a rectangular view. Voila. Now we have here the thyroid. Now there is part of the thyroid lobe I cannot see, the peripheral part. Now if I activated the wide view, can also be named trapezoid view or virtual complex, what will happen? The machine will make the waves on the periphery extend a little bit outwards. So what happened? Now I can see the rest of the thyroid lobe and the carotid in its vicinity. So this is a better picture when you want to appreciate the whole of the thyroid lobe in its continuity. The same thing on the other side here. You can see the rest of the thyroid lobe and the carotid. So this picture can give you a better view should you want to assess all of the thyroid in its continuity along with the carotid as well. Okay, so it is this function is called wide view. As we can see, it is giving us a wider view. It can also be named a trapezoid view. This shape, resulting shape is like a trapezoid, or it can also be called virtual complex. And this is a nice labeling, actually, nice name, because what we have done here is basically we have transformed our superficial linear probe into a little bit like a convex probe, but of course it hasn't changed, so it is a virtual complex. Okay, so let's see another example. Okay. Now this picture, is it a normal superficial linear probe or normal picture of the carotid, or we have here used the wide view? Look at what the periphery, look at the edges. These are straight and vertical. So this is the normal rectangular picture. What will happen when we activate the wide view? Voila. This is what will happen. We'll have a wider view. We'll have a wider view here on the periphery. And what will happen to the edges? It is tapered outwards. And this is how we can tell that this is a picture with the wide view function activated. That we can see the bifurcation, so we can see a little bit more. We can always tell by looking at the edges and see how they go. Okay? Another example. I'm sorry, let's look at it. Okay, another example. Here, What about this picture? Oh, okay. I'll let you just tell me first. This picture, is it with the wide view or not? Yes, that's right. I was just about to draw it as usual. It is not with the wide view. It is the normal rectangular view because the edges are what? The edges are straight, and this is the rectangular view. What about this? Look at the edges. They are tapered, such downwards. This is with the white convex, and now I can see the whole of the thyroid lobe in its continuity. Okay, voila. Okay. Now, does this function exist in the already convex probe, as in the abdominal and the transvaginal? Well, it exists in some of, sorry, it exists in some of the machines, but not in all machines. Here we can extend the edges a little bit more to cover an even more wider area. So yeah, it exists, but not in all machines. Yeah, I can see that you are wondering now, does this function affect the image quality? Well, not much, not really. It does not really affect the image quality. Okay, so now we have covered all of the depth. Remember our mnemonic here in the B mode, we have the R, B, D. Now we finished the D, the depth, the zoom, and the wide view. Now we are in the brightness or the gain. In the brightness or in the gain, we discussed three things as well. The overall gain or brightness, the TGC, those little sliders here, and something called dynamic range, also very interesting. Okay, so let's see. Now, the overall gain is usually controlled by this. Okay, I'm sorry. Let's just look at it here. It's controlled by this rotatory knob, usually named B or brightness. Okay. And if you moved it this way and you can move it the other way, it's rotatory knob. Might be a little bit different in your machine, but usually it is like this. So you can move it this way or the other. One way would make your picture brighter. The other, of course, according to your machine, will make it darker. So this controls the overall gain, controls the brightness or the darkness in your picture as a whole. How is that? Let's see. Okay, we have here two pictures. Now what I want you to tell me is which picture is darker and which picture is brighter. Okay? How about this picture? Yeah, that's right. This is brighter. And what about this one? Yeah, of course it would be the darker. It has to be one or the other. Okay, so let's get back to what we have promised to do, understanding all of your picture. Okay, so let's decipher those equations. And I'm really curious to know, have you ever really thought about these numbers before, or did they just there for some mystical reason, or for the engineers themselves, or they are nuclear equations, or I don't know what? Well, they're quite simple. Once you understood them, you can really get what they refer to. Okay, let's see one by one. Let's take this. What is this? Okay, this is your gain that we are discussing now. And one is 51 and the other is 83. So can you tell me, and this is numbering, this is B1 and this is B2. So can you tell me which picture is B1 and the other is B2? B1 has gain of 86 and B2 has gain of 51. Okay, I'll give you a second to think. Okay, I see that some of you's got it right. Bravo, bravo. This is the B2. Why? Because it has less gain. It's darker. Voila. And this is the B1 because it has more gain. Its gain is 86. So this is the B1 and this is the B2. So we have understood this. What about this D? Anyone has any idea? I think you can really get it easily. This is the depth that we have calibrated, and the depth here is okay. The carotid is in the center of your image, it's filling it. We don't have any part of the image without use. So this is the depth. What about this? It is the frequency or harmonic frequency. It is here 10 megahertz. Okay. What about this? This is something called frame rate. Now, what does this frame rate do? Well, the frame rate is in the images per second. Okay, frames per second. With the images per second. To understand this, do you remember the movies, the old classical cinematic experiences in the beginning, the movies like Charlie Chaplin, when he was moving in a very funny way with his act and all this? Well, there was this terrible lag, and this make it even more comical because the number of the images per second were low, and that's why it has this lag and slowness, and it's even more comical. But now, of course, there's more images per second with the cinematic mode or the cine or the live mode, or the movie and the film is more swift. Okay, so you can't really see this lag like before. So this is what the frame rate is about. Okay, so now we have understood more of these Tolsomans. Okay, so you will no longer ignore them. Okay, now we have here another two images. Now, I'm quite sure that you are now wondering, how can you set it? Well, I don't have an ideal preset for the game. This is how your eyes are comfortable watching or working. Here we have a slightly, not black, but let's say it's dark image. And here it is bright image. Now, is this too bright? Is this too dark? This depends on how you would prefer to see things, just like your mobile. I cannot tell you how to set the brightness in your mobile. This is how your eyes are comfortable. But pay attention. You have to set your brightness not to be very dark, that there might be soft tissue, shadows, or structures that you don't see because it's very dark, and not to be very bright so you can imagine things and there are illusions and there are a myriad of shadows that are not really there, but just the image is too bright. So you have to adjust it. You can adjust it the way you like, but without affecting the diagnostic ability of your image, without affecting the structures you are seeing or the composition of the image. Okay, so let's see here what we have here. We have two pictures. Okay, again, the carotid, and this is the B1. Okay, now we can read it, and now we have the B2. Which is the B1 and which is the B2? Okay, we have one with the gain 34 and one with the gain 51. Which is which? Okay, I see that now you can really appreciate it easily. This is the B1 with the gain of 34 because it is the less gain, so it is less bright. And this one with the gain of 51 because it is more bright. Okay, so we can now appreciate the difference, okay, in the overall gain here. Voila. Now we will get into another point in the gain. Okay, here we have something called TGC. Now, what are this TGC? Normally the TGC has got this set of sliders, okay, set of scroll bars, mini scroll bars or sliders, whatever you name it, with triangular like this, having the narrow end and the wide end both at the extremities of these many scroll bars. Okay, it can be virtual or can be real as in this machine. Now you can move them right or left. Now, if you have your triangle just as like this one, when you move them toward the narrow end, then towards the dark, and when you move them towards the wide area, then towards the bright. Okay, now this controls what? It controls the gain of the brightness. So someone might ask me, then what is the difference between this TGC that controls the brightness and the one we've just discussed, the overall gain, this rotatory knob? Now, in order to illustrate this, I'm going to, explain it a little bit differently. Okay. We have here our image. And we have here the set of sliders. With the narrow end here. Now, this set of sliders, each one control one part of the image. So this little slider controls let's say the upper sector, and this one controls the sector that's below, and this one controls the sector below, and so forth. So the TGC does what? It controls the brightness, but in sectors, in every part of the image. This is allow you to control your gain in every part of the image. But what about the knob here? Here the knob, when you move it this way or the other, it controls the whole of the image as a whole. It controls the whole of the image. But the TGC, every little slider controls one sector of the image. This allows more control over each part of the image. So this is the difference between the TGC and the gain. Let's see how it works using a real picture as usual. So what we have here, these are our set of sliders, and this is the resulting image. Now when we move the slider to the far end, now our triangular is as such. So here it is at its maximum, so it will give us maximum brightness. This is the part usually with the gel. Now when we have moved these middle two sliders to the far end, where the narrow end is, that is the dark, what happened? No picture, absolute black. Again, when we move the lower sliders to the maximum end, where the wide end is, that is maximum brightness. So this is how we can control every part of the image by the TGC. Now if we set them all in the middle, we will see, as in here, the image will be in the shades of gray, no black, no white. To line the middle as such. Again, to illustrate how it works. Now we have here the sliders more or less in the middle, so our picture all are in different shades of gray. Now here we've played around a little in order to show you the function. The first two are in here. Here is our triangle. I'm constantly drawing it because in your machine it might be the other way around. So you have to pay attention that all of this is based on the assumption that your narrow end is at this end and the wide end is at the other. So just this is why I am drawing it, in order to remind you that this is how my machine is put. So here, when the two sliders are in the maximum narrow end, are in the black end, what happens? No picture. Now when the when the two below are in the maximum bright end, what will happen? White, absolute brightness. Now these are black, and the other way white, and this black. We are playing around in order to show you how you can control each sector by these two little sliders. Now of course the main question here is how to set them right. I know that now I can control every sector, but how I can control it right, how I can set it and calibrate it right so that it can help me in my examination. Now as we all know that as the ultrasound go downwards and penetrate the body more, what will happen? Their power will start to weaken. So in order to compensate for this weakness, it it is advisable that you set your TGC in step ladder manner. Okay, so as we go downward, we will increase the brightness gradually to compensate for the weakness in the waves, so that will give us a more or less balanced image. Okay, as if the power of the waves are in equilibrium or are balanced. We have compensated for the weakness of the waves by increasing the brightness. Okay, provided of course that you do not go till the end of your sidebar, because this is the absolute black. So if you move the slider to this point, you will not see anything. So don't start from the end after it like this, in step ladder manner. Okay, and also do not block the image, because if you reach like this, it will give you absolute white. You won't see anything as well. So just calibrate it this way, avoiding the extreme ends. Now let's see how it works as such. Okay, of course this is of special importance in the examinations that involve more deep structures, as in the abdomen. Now we have here a picture of the liver. Here the TGC are set in vertical manner. They are all set under each other. Okay, like this. These are the TGC. Okay, vertical as such. Now what will happen? We will lose the lower part of the image due to the resulting weakness in the lower waves, or in the waves that have reached this depth. Okay, so what will we do? We will calibrate the TGC in step ladder manner. Voila! Now the lower part of the liver can be seen thanks to the increased brightness that has compensated for the weakness in the waves. So I think that you can agree with me that this picture is a little bit better. Okay, so let's wrap things now. What we have discussed. Okay. Okay, now we are discussing the B mode. The first of the lecture, we've just been warming up, and we've chosen the patient and the type of examination and the transducer. And then we've gotten to the real part, the B mode. We have our mnemonic. What was it? Remember the RBCs, and we substituted the C with what? The subject of our course, the Doppler. So we have RBD. Okay, so as we have just said, the resolution, the R is for resolution, and the B is for brightness, and the D is for the depth. Okay, now what we have discussed is this one and this one. Let's see. In the depth, there was the depth itself. Okay, and then the zooming function, we've chosen one part, and then the wide view or the trapezoid view or the virtual convex. Okay, that is the depth. What about the brightness? We've got the overall brightness or the overall gain. Okay, and then we have the TGC. Now there will remain what the dynamic range, the one we're going to discuss in just few seconds. Okay.